Welcome to my little Roadrunner pathing generation tutorial. Let's get started. So you want to generate a path in Roadrunner. That is usually an easy task if you understand all of the different things that go into that path generation. If you don't, it's really not fun. I speak from experience. My freshman year was not great trying to generate Roadrunner paths with no knowledge of how tangents worked. So let's do a quick explanation. Roadrunner generates its path based on point coordinates and tangent angles. In the case of a line, a tangent angle refers to the angle at which that line travels. So if you're familiar with the line2 function in Roadrunner, you'll notice that all you pass into it is an x-coordinate, right? So let's say this is the point 0, 0. Pardon my horrific drawing skills. And this is the point, or this is the x line, like 24. Let's call it 24. When you do the line2 function, normally it will assume a tangent of 0 degrees, which means you will travel at a 0-degree angle until you hit the point. As you feed different tangent angles into the line function, you can change the angle in which you approach that coordinate. There are some limitations to this though. For example, you can't put in an angle of 90 degrees, or anything that would travel the opposite direction of the x-coordinate you're trying to reach, because then you would never complete the line and Roadrunner will throw you an error. Let's look at a quick code example of this line to x behavior. So let's say we're starting at 0, 0, 0, right? Just dead in the origin. And we want to travel 24 inches in that direction, right? Let's run that on Meep and see what it does. We travel 24 inches in a straight line. We haven't specified a tangent angle, so again, Roadrunner assumes we're traveling at a 0-degree angle. But you can see that as we use the .setTangent function to specify different angles at which we want to travel, like 45 degrees, when we run the Meep simulation, we'll travel at a different angle to reach that point. So you'll see we travel at a 45-degree angle until we hit that x of 24. Pretty awesome. We can do the same with the y lines as well. So let's say we want to go to a y of 24 at an angle of 30 degrees. We'll travel in a straight line at a 30-degree angle until we hit that y coordinate. Lines are pretty simple. I wouldn't recommend using them purely because you can't, by default, enter a specific set of coordinates you want to reach. You can calculate the angle you'd need to travel to reach a specific coordinate if you'd like to with some basic trig, but it's generally easier to use splines because you can specify the start and end points. So I would highly recommend using splines instead if you can. So let's go over how tangents apply to splines, since we're talking about that now. In the context of a spline, I apologize for any background noise, the tangents refer to the start angle in which you travel and the way in which you approach the endpoint. Sounds a little confusing. Let's get a little bit more specific. Let's say this is our robot at, again, 0, 0, 0, right? And we want to travel to a point over here, right? So let's start by saying we want to start moving towards that point with an angle of 0 degrees. Then, pardon me, we want to approach this point coming on this way at an angle of 90 degrees. That would generate a spline shaped vaguely like this, right? Pretty nice, pretty clean. How would we go about doing that? Well, we'd want to specify a start tangent, or the angle at which we start traveling, of 0 degrees, and an end tangent, the angle in which we approach the endpoint, of 90 degrees. How would we do that? So let's say we do a spline2, just that's the default spline function. We specify the point we want to travel to. So let's say that's a y of 10 or 24, because that's a pretty large one, and an x of 40. So 40, 24. Great. Now we want to specify the start tangent. We can do that by, again, using the setTangent function. And like we said in the example earlier, we want to start moving in a straight line at 0 degrees. And we want to approach the endpoint at an angle of 90 degrees. Let's run that simulation and see what happens. There you go. There's your nice spline shape. And we can change this a lot. We can tweak this to whatever we want. Let's say we want to start moving at a 30-degree angle and approach it at a 0-degree angle, so from the side. We can do that as well, very, very easily. Awesome. And you might notice that there is some weird heading behavior going on. Now it's probably a good time to cover the different ways your heading can interpolate while you're traveling on a spline. By default, the spline2 function moves your robot's heading with the shape of the curve. That's the best and easiest way to understand that. There is a much more technical math explanation, but I think that's a bit out of the scope of this video. If you want to, let's say, lock your heading angle, you can use a spline to constant heading. And what that will do is it'll prevent your robot from rotating at all during your spline trajectory. Can be seen very clearly here. Awesome. Then, if you want to go to, say, a specific heading at the end of the spline, you can use either spline to linear heading or spline to spline heading. These require you to pass a pose 2D instead of a vector 2D, which is worth noting, and you'll have to include a heading value in that. So let's say we want to end at an angle of, I don't know, 40. We can run that same spline, and you can see with spline heading, the heading will change vaguely along with the rate of change of the curve. So you can see that it amps up as the curve goes on, and it doesn't change linearly. Spline to linear heading just changes linearly. It's pretty simple to understand, and you can see as the curve progresses, it rotates at a constant rate as opposed to along with your progress on the curve. Pretty nice. The main difference between these in terms of use cases is your ability to chain them. When you start chaining different splines, different lines, all these other things, you generally want to use spline to spline heading or just the raw spline2 function, and line to spline heading or just the raw line function. Constant headings can also be changed, but it starts to get a little wacky when you start changing heading a ton between different trajectories. So I can show you another example of a solid spline. Let's say we want to travel like this at a starting angle where we're going straight, where we also end going straight on, right? So that spline would generate looking something like that, right? We can do that by, let's say we're going to start facing upwards, so at an angle of 90 degrees. We can set our start tangent and end tangent to be the same. And then, while we're doing that, we can have whatever translation we'd like to do. So let's say here, similar trajectory. There you go. That's probably one of the most common spline shapes you're going to see this season, mostly because of, the specimen and push autos, right? All are going to have that similar structure, and you can do this by having your tangents on your spline both equal to 90 degrees. That way you're always going in at a straight angle. If you're going backwards, they need to be negative 90 degrees, or if you're weird, 270. It's honestly really simple. It seems very complicated at first when you start working with splines, what the tangents all mean and how it all works, but in actuality, it's shockingly simple. I hope this very brief tutorial has helped to some degree with your understanding of Roadrunner Pass. If you have any questions, feel free to DM me on Discord at ultimaker_Kira. I stole the username. Have a good day, everybody, and thank you for watching.